Okay, for the prior three problems, we spent certainly time at the whiteboard. It should be becoming a little more obvious what we're doing at this point. We're writing down the function. Whoops. We're making some attempt to factor that function. Relatively easy to factor that, by the way. We're writing down the first derivative and making some attempt to factor the first derivative. We're writing a second derivative down and making some attempt to factor that. All right? Now, of course, when I do that, we'll get to the picture later, but as I do this over here, I analyze a bunch of things. And one thing I analyze is just on a number line, I analyze the function itself. And it's going to take on zeros at 1/2, and another zero would be at minus 2/3. And this is the analysis of this thing over here. Now, if you start to realize that this fact here is always positive. So really, we kind of just rest on just analyzing this now. So after 1/2, it's going to be positive. And below the 1/2, it's always going to be negative, except at the place where it's 0. Right? So looking at it, I know the picture, and we'll get to the picture in a second. This is a very crude picture, by the way. We know at minus 2/3, we have a root. But what do I know about it? I know it's negative, negative. I know it's got a y-intercept at minus 4. And then I know it comes swinging back up at 1/2 and becomes positive. So it looks sort of like this, cubic, right? That's a very rough picture. I want to go over here, I want to point out in the rough picture, this is minus 2/3. It's a better picture. And this is the number 1/2. What's this number over here? It's the y-intercept. And what's the y-intercept? It's just simply going to be minus 4, as indicated here. Okay? So that part's done, right? Now, is my shape as good as their shape? No, I'm missing, that relative minimum that they have so nicely indicated here. So what I want to do now is I want to go to the next thing. We're done with the function now. And I want to concentrate on the next guy. And the next guy for me is looking at the first derivative, which generally is easier to look at than the function itself. And I factor that. And what do I notice about this over here? It's got zeros. That's where it's changing its sign. Where does it change its sign? At minus 2/3. And at what other number? That would be 1/9. Sign analysis. To the right of 1/9, it's going to be positive. Between minus 2/3 and 1/9, it's going to be negative. That means it's going down, up. I'll do this over here. Below minus 2/3, it's going to be positive. So at minus 2/3, we have a relative maximum. Clearly indicate this. This is also a relative max. At 1/9, we have a relative minimum. This is the relative minimum, and that occurs at 1/9, f of 1/9. I'm not going to compute the number, by the way. One last thing, point of inflection. That's a second derivative. What's that going to be? Minus 5/18. To the right of it, it's positive. To the left of that number, it's negative. Concave down, concave up. So at minus 5/18, wow, that's a tough number, huh? Somewhere over here, there's a point of inflection. That's minus, let's make sure I'm saying that right, minus 5/18, f of minus 5/18. Again, looking at the picture, I want to point out what I mean by that. Concave down, and then it goes concave up. All right? What they ask about the roots? We got the roots. We got the y-intercept, relatively easy, relative minimum, relative maximum. Again, we're depending on prior skills to do that. Thank you.